Okay, so I'm just going to go over homework number 8. All right, so we have table of values here. We have a graph of H. Okay, and we have a function that's defined as f of x equals cosine of 2x plus e to the sine x. G is a differentiable function. Again, that just means a smooth curve. Table gives values of g and its derivative. H is the function whose graph consisting of 5 line segments. Okay. Part A says find the slope of the line tangent to the graph of f at x equals pi. So we're going to rely simply on our f of x function here. So to find the slope, we need to involve the derivative. And to involve the derivative, we have to involve all these rules here, right? So a couple of rules here that we can apply. Cosine of u becomes negative sine of u times u prime. Right. E to the u is just e to the u times u prime. And then sine of u is cosine of u times u prime. Okay. Find the slope. Let's find the derivative first. Actually, yeah, it's not asking for a tangent line, so just the slope. Okay, so f prime. All right, so what does cosine of 2x become?
Would it be negative sine 2x times 2?
Yeah, we just follow what the rule says. Our u value is 2x, so yeah. So we're done with that term. Moving on to e to the sine of x. So what do you think is the derivative of e to the sine of x?
Would it be so e sine to the x times like cosine of x?
Right. Yeah. So
I suppose we try to mix the two rules together, kind of.
Right. Yeah. E to the u is part of the original derivative, the original function's derivative. So we're just going to copy that down exactly as we see it. But then we got to do u prime, which is asking for the exponent's derivative. So exponent is sine, so sine's derivative is cosine. So that's going to take the place of this u prime here.
Okay.
All right, so now that we have our derivative, we can evaluate the derivative, and that will take us to the slope. I'm going to put I'll leave the 2 out in front here. All right, so sine of 2 pi, this is going to be 0. So it's going to wipe this whole thing out. E to the sine of pi is 0 as well, but anything to the 0 is not going to be 0, it's going to be 1. So it's going to be e to the 0, which is 1, times cosine of pi, which is negative 1. 1 times negative 1 is negative 1. All right. Any questions? How does that look?
Looks good.
Okay. Part B, let k be the function defined by k of x. Find the derivative at pi. So first things first, though, this is also asking for slope, but we have to find the derivative first before we can involve the slope. So what's involved here to find the derivative of that function?
Is that chain rule?
Yeah, this one is chain rule, right? There's a f of x inside h of x. This is a function within a function. We got to apply chain rule. So let's find k prime. We have the outside derivative first, so h becomes h prime. And we keep the inside intact times the inside function's derivative, so f becomes f prime. All right, so there's our derivative. Now we can insert pi in for all the x's. And then piece by piece, we're going to try to eventually get these nested values into a numeric answer. Whoops. Go ahead and replace that x with pi. Okay, so we need to find f of pi, right? F of pi, we're going to go back to the original function and actually figure out what that value is. So I'm going to go over here and plug in to find f of pi. Okay, so cosine of 2 pi is 1. E to the 0 is 1. 1 plus 1 is 2. Okay, so 2 is going to replace this f of pi here. All right. So f of pi is going to get replaced with 2. All right, so we're moving on to h here. So h prime of 2. So we're asking for the slope of the h graph at 2. The slope of the h graph at 2 is going to be here, right? So what's the slope of the h graph at 2?
Negative 1/3.
Yeah, we're just going to find the slope of this line. Negative slope, down 1 over 3. Exactly right. Okay. And then f prime of pi, well, that's good. We can carry that over from part A. Negative 1/3 times negative 1 is a positive 1/3. All right, any questions?
So you can just carry over the f prime of pi from part A to part B.
Yeah, sometimes these free response questions are connected. It's not always, but a lot of times I think it's a good idea to always look to see, wait, is there something fast I can just bring down?
Mm-hmm.
And Yeah, there's quite a few instances when we're actually pulling information from the previous part as we build our answer to the current section.
Okay, thanks.
Mm. All right, part C. Let m be the function defined here. Find m prime of 2. Again, before we find slope, we have to find the derivative. To find the derivative, what special method is involved here?
Would this just be product rule?
Yeah, product rule with a little bit of chain rule here. Okay, but yeah, product rule. There's my F, here's my G. All right, so I'm going to build my product rule here, build my derivative. All right, so what's g of negative 2x's derivative?
Would we just put g prime of negative 2x? Or is there like more we need to find?
Okay, so yeah, it's in function notation, so it needs to stay as function notation. So g prime of negative 2x. Is that it for f prime? Or for this portion's derivative?
No, you have to multiply by 2.
Close, multiply by
Oh, negative 2, my bad.
negative 2. Okay, so this is a little bit of chain rule here. We got to, that inside portion of negative 2x, we got to worry about that. So g prime of negative 2x times negative 2. So that's going to be the full derivative of that g of negative 2x. Okay, my g function is the h. Back to the f. And then what's g prime?
H prime.
Just h prime, okay. All right, so we got through the hard part. Now we can just replace all the x's with 2 and see if we can pull the rest of the information from either the table or from the function. Okay. Replace every x with with positive 2. All right, so we need to make some substitutions here, right? So g prime of negative 4, we go to our table here. Okay. G prime of negative 4 is just negative 1. Okay, so I have first two pieces figured out, h prime of 2. So h prime of 2, I think we found that from a previous section, right? We just, the slope of our h graph at 2 is negative 1/3. G of -4. We go to our table here, G of -4, just 5. Oh, I messed up here, sorry. H of x, not H prime. My bad. So it's asked, we need to find H of 2, not H prime. H prime 2 is over here. We need to find H of 2 here. So H of 2 is, what is that ordered pair here? What's that Y value right there? It's going to be a fractional value. Any idea what H of 2 is?
It'd be like -2/3.
Yeah, -2/3. All right, so imagine you're just going down by -1/3, -1/3, -2/3, -3/3. Yeah, so.
So we would just use like slope to find that, because I kind of just guessed, but I didn't.
No, I guess we could use slope, but I think we can kind of just look at this and say, well, it takes, my slope is, yeah, I guess so. You can think in terms of slope, or you can think in terms of, well, my graph is going down just a linear slope here, and it's going to go, it's going to cover the same distance between 0 and -1 over the course of the 3 units. So, yeah.
Okay.
So it is a little bit of just kind of, reasoning it out and guessing as well. Okay, so -2/3 there. And then H prime of 2, now that's going to be -1/3, right? Clean this up here. Okay, any questions? Okay. Let's look at part D here. Is there a number C in the closed interval such that G prime of C is equal to -4? So whenever I see this type of wording, I'm always thinking, all right, probably going to be a mean value theorem or Rolle's theorem. So basically, over the course of my G graph, can I guarantee a slope of G being -4? And I think mean value theorem can maybe help us with that. Okay, so here's the graph of G. We know that G is differentiable functions, so we know it's going to fulfill the conditions that is required of mean value theorem. So I'm just going to go ahead and list out those conditions here. So if we want to prove mean value theorem, let's find the slope between the endpoints All right, f of b minus f of a over b minus a. If the slope between the endpoints, well, if it produces -4, then we know there must be a exact slope of -4 somewhere along the curve. So now we can turn our attention to this, produce a value that can allow us to guarantee that. Right, so we just pick out values from our table here. G of -3 is just 2. G of -5 is 10. So we say 2 minus 10 over -3 minus -5. And is this going to come out nice here? So 2 minus 10 is -8. -3 plus 5 is 2. So yes, right. The slope between the endpoints is -4, so there must be an exact slope of -4 somewhere along the graph as well. All right, so you don't have to do this here, but just a visual. The slope between the endpoints happens to be -4. So by mean value theorem, there must be another place on the graph that has an exact steepness of -4 at a specific moment. By mean value theorem, there must be at least one value, one C value, where G prime of C is equal to -4 on the interval from -5 to -3. All right, any question with this first FRQ?
I just have a question about the last part. And this is kind of hypothetical, but if G prime of C was to equal -2 or something, in the explanation we say that we just say that it doesn't, MVC wouldn't work, or?
Oh, right. So you mean if the slope between the endpoints did not match -4? Yeah, then we'll say that by mean value theorem, this conclusion is inconclusive because, or it doesn't apply with the endpoints given to us.
Okay.
Yeah. Maybe it'll work for a different set of endpoints, right? But with these set of endpoints, we need, if it doesn't match, then maybe it exists, but we can't guarantee it, not with the limited amount of information we have.
Okay, thank you.
Okay. All right, Nolan, you good?
Yes, thank you.
Okay, let's go to back here. Table of values, we have function f and g have continuous second derivatives. The table above gives values of the function and the derivatives as selected values of x. Yeah, so very much the same. We're just going through chain rule like what we did the previous problem. But now we have to find order pairs and slope because we need to write the equation of the tangent line. Right, so recognizing the need for chain rule here. All right, so tangent line equation. Ultimately, we want to find point. We want to find slope. And then we'll dump it all into point slope form. Okay. Let's do K prime. Outside function's derivative times inside function's derivative. So outside function's derivative is f prime of g of x times the inside function's derivative, so times g prime. Okay, maybe I should have found order pair first. Okay, well, we can do both. Slope at 3. Okay, so work from inside out. Let's figure out the part that is more straightforward. G of 3. All right, that's going to be 6 here. So I replaced G of 3 with 6. Now we're having a much easier time, as now we can just evaluate f prime of 6. F prime of 6 is at 5. G prime of 3 is at 2. Okay, K prime of 3 equals 10, so there's our slope. We need to find an order pair. Well, we have our x value. We'll insert that x equals 3 into f of g of x. Okay, one piece at a time. G of 3 is 6. And finally, f of 6 is just going to be 5.
Maybe 4.
I'm sorry, 4. My bad. Yeah. Order pair, not the derivative. F of 6 equals 4. Okay, so we have our x and y value, 3, 4. Okay, there's our order pair, there's our slope. Now point slope form. All right, part B. Let H equals G over F, find H prime. So we're going to go through quotient rule here because we're dividing two separate expressions and asking for its derivative. right, notice we can't quite say the same thing as before. We can't quite say f prime g minus fg prime all over g squared because now my denominator is f and my numerator is g, so everything's kind of flipped around. So it's the derivative of the top times the bottom minus the times the top times derivative of the denominator all over the denominator squared. All right, replace every x with 1. All right, so we just go to our table here. G prime of 1, be 8. F of 1, it's negative 6. G of 1, which is 2. F prime of 1 is 3. F of 1 squared, it's negative 6 quantity squared. All right, any questions with part B? Okay, we saw a little bit of this yesterday in class. Having to go through use substitution and first theorem. We know use substitution to take care of the 2x, and we know f double prime is going to move up to f prime after we apply that integral. All right, use substitution first. Target that portion inside the parentheses as our u value. Make our substitutions. Push that 2 out as a 1/2. Take the antiderivative, f double prime just becomes f prime. And once you have the antiderivative, if you want, maybe it's faster for some of you, just bring that back in terms of x, and then you can use the original bounds. upper bound first, 3 in for x. We get 2 times 3, which is 6. Lower bound next, 1 in for 2x. We go to our table. We want to find f prime of 6 and f prime of 2. There's f prime of 6. There's f prime of 2. Five halves plus 2 halves, 7 halves. All right, any questions here?
Nope.
Okay, so I put up a morning review worksheet number 4 that I'll probably want to spend, yeah, I'll probably spend time tomorrow afternoon going over that in addition to Thursday morning. So I think that's a really good review that's going to, highlight all the things that you're going to be expecting on the quiz. So I encourage you guys to work through that beforehand if you can. I'm working on the key, so I'll upload the key sometime later today. But I have the student copy up already, so hopefully, I think if you can focus on that, feel good about that, you should not be surprised with anything that shows up. So. All right, any questions? All right, maybe I'll see you guys tomorrow in the help session, but Nolan, I'll see you in class tomorrow.
Thanks, Mr. Yang. Have a good one.
All right, you too. See you, Joey. Bye, Nolan.